Welcome to The Explainer. Today, we're diving into one of the most powerful, most violent events in the entire universe, the collision of two black holes. We're going to explore how in the world we can hear these events and what they're telling us about the cosmos. So think about this question. For pretty much all of human history, it was pure science fiction, right? The universe, as far as we knew, was silent. But that all changed just a few years ago when we developed a completely new way to listen in. On that day, humanity basically gained a new sense. It's the day we first heard the cosmos. Now, Albert Einstein had predicted this was possible 100 years earlier, but this was the moment his wild theory became a reality we could actually measure. So, how do we finally hear this thing? Okay, so this first sound, which has the very catchy name GW150914, was a signal from two black holes merging together. And get this, the event happened 1.3 billion years ago. The message only just got here. But what was the message even made of?
Well, the sound we heard wasn't sound in the way you're thinking of it, traveling through air. Nope. These were gravitational waves, literal ripples in the fabric of space-time itself, caused by some of the most massive objects in the universe smashing into each other.
And this whole cosmic drama, it plays out in three pretty distinct acts. Each one leaves its own unique signature in those gravitational waves, kind of like a story with a beginning, a middle, and an end. So let's jump into that first phase, the build-up, the in-spiral. And this isn't some quick thing. We're talking about a cosmic dance that can take billions of years before it gets to the grand finale. It all starts with two huge stars that were born together. They live their lives, they die, they collapse into black holes, but they stay trapped in each other's gravity. And as they orbit, they're constantly shedding energy as gravitational waves, which makes their orbit shrink. At first, really, really slowly, and then all at once. And this is what creates the signature sound that scientists are listening for. As those black holes get closer and speed up, the pitch of their signal goes up and up. It's this very specific whoop sound, a chirp, that tells them a merger is about to happen. Okay, now for the climax, the merger itself. This is a moment of just unimaginable violence. It lasts for only a fraction of a second, but it is without a doubt the most powerful event the universe is capable of. I mean, this is where the physics just gets completely nuts. The gravity is so intense that our normal equations just don't work anymore. To figure out what's happening here, scientists need supercomputers to simulate the final violent plunge. But, what kind of energy are we actually talking about? The amount of energy is just staggering. For that very first detection, GW150914, this is how much mass was just annihilated at the peak of the merger. 3 times the mass of our own sun. And the crucial thing here is that mass didn't just vanish. It was transformed in an instant into pure, raw energy that literally shook the fabric of space-time. This is Einstein's E equals mc squared on the most cosmic, mind-blowing scale you can imagine. To put that into perspective, for that one brief moment, the single invisible merger outshone the light from every single star and the entire observable universe combined. Just an unbelievable event of pure gravitational power. So after the collision, all that violence just fades away. The universe settles down, and where there were two black holes, now there's just one. A brand new, more massive black hole is born from the chaos. This final part of the signal is called the ring down. The new black hole is all misshapen and chaotic at first, so it quickly sheds all those imperfections by vibrating, just like a bell that's been struck, until it settles down into a perfect, simple sphere. And this ring down points to one of the most profound and honestly elegant ideas in all of physics. It says that despite all the chaos of the merger, the final black hole is incredibly simple. It's like if you take two really intricate, unique ice sculptures and melt them into one bucket of water. All that original detail is just gone forever. Same thing happens here. So all that complexity, the history of the two parent black holes, how they were oriented, all their individual properties, it's just gone, wiped out. All that's left is an object defined by just two things, its final mass and its final spin. That's it. That first detection back in 2015, that wasn't an ending. It was the birth of a whole new field of science. It was the beginning of an era of gravitational wave astronomy, a new way to see, or maybe I should say, hear the universe.
And since that first one, well, observatories like LIGO and Virgo have detected over 200 of these mergers. Each one is a new piece of data, a new note in this incredible cosmic symphony.
And with every new detection, we learn more. Each chirp is another test of Einstein's theory of relativity in the most violent conditions imaginable. And he keeps being right. We're finding black holes in sizes we never knew could exist, and we're literally starting to map the unseen universe.
And the future? It's even more exciting. The next generation of detectors will actually be in space, and they'll be able to hear the slow, deep rumbles of the true giants, the supermassive black holes at the centers of galaxies, as they spiral in towards each other. So, the big takeaway here is that we have opened a brand new window onto the universe, one that doesn't use light at all. We are only just beginning to listen to the gravitational cosmos, and it just makes you wonder, what else might be here?